and this is the other part, which indeed, yeah, tools are important, but in particular in the case of software is immaterial. But we need a shape to reason about anything. And as a consequence, well, the shape of anything in software, anything in the computer is provided by our tools. It's the tools that provide the shape to that we need to reason, which means that given that, the tools are essential. They are not something that are optional, right? And if you think about today, if you think about how we think about our tools, and people just say, oh, I'm going to use this tool or that tool, and they are considered to be equivalent, without a lot of, nobody is really paying attention to the characteristics of those tools. And so what Glamorous Toolkit does is it starts from this idea that everything in software, there's no dominant perspective in anything in software. And as a consequence, right, we made this to be the core property of the system, and as a consequence, everything else fell into place. And if you add to that the fact that every boundary in software is arbitrary, it means that there's no anything that we have learned by, for example, through the interaction that we had with users, and we learn how do you build applications that make better sense for users. All of those lessons are as important everywhere else in the system, because any boundary is arbitrary. So when you combine those things, that's basically when you get the Glamorous Toolkit, because it's basically a language. So not the small talk language, but we look at the environment as being a language that you can combine in many different ways. So maybe to exemplify this one. So if we look here, here's a small integer, and if I alt click here on let's say I look here on integer, and if I alt click there, you can see how the implementation of this extension is. And so this is like the GT integer 4 method, which is implemented in an integer class, which is a superclass of small integer. Like if I look here in the meta, there's a superclass there. So this is now the implementation, which is reasonably small. And what we see here is that this is something called a pragma. So it's like an annotation. If it would be in Java, this would be an annotation. So an interesting problem here is like, so views are very important throughout the whole environment. And these are the most basic things we have. And they are hosted by the inspector, and the inspector essentially doesn't assume anything about the object. It simply says, I have an object, you object, could you please tell me what kind of views can I display about you? Very much like how we don't assume that we know what the string representation an object will have, and then we ask the object, could you display a toString? And then you get a toString back. Okay, so one problem here is, I want to now learn about this. I want to learn how to create these views. Of course, I could go here and I could say, where is it? Inspect the views. I can go in this slideshow here, and then I can start learning about it. But still, seeing more examples would be quite useful. So if I go back now into my playground, and I'll say here, well, I want these GT views, and here I want to query my system. And well, I have this little triangle over here. If I expand it, I can see that this is actually an extension that we made to symbol. So symbol is a generic object, which basically allows us to get a filter object given this for this pragma. So if I execute that, what do I get? I get a filter object. And this filter object now knows how to present itself. So one of these views is the live view, which if I look at it, is basically a bunch of editors. So I can go and start writing code here. So what do I have here? I have here on the left, I have transformed my playground where I am normally expected to work with maybe domain objects. And I transformed the playground into a query box. And now I'm writing code in an inspector. This is how far we go, or we can go. Because the question is, how do you call this tool? And you would be hard pressed, right? Because how often do you define activities based on the names of the tools, on the affordability of the tools that offer some of the functionality, right? So maybe you will do search in somewhere and then you'll edit somewhere else, but you will never be able to combine those because they are just, there are boundaries there, which are just, they shouldn't exist. They do. And then we start to create all sorts of patterns around those boundaries. And so this is what happens once the system becomes highly, we call it moldable. And the idea there is that you have a context and you want the tool to mold to your context rather than you to mold to whatever the tool allows you to do.
This really chimes well with this other thing that we have been saying, that I mean, in the context of design tools, we say instead of making design tools, make things designable, right?
Mm-hmm.
Some things that people use are just like, as you say, moldable, modifiable by themselves. You don't even need to have a tool to change them, and some things aren't. And it looks like in the world of, you know, software, which we're just working with abstractions, it's possible to make things moldable, and good things come out of that when that happens. I wanted to ask, could such an environment be realized in a different programming language? Not that I dislike, I love Smalltalk. It's really interesting. It's just I'm just curious which parts of it come from like that substrate of the language, and which of it is like not.
So the question, I look at this question in two ways. We get this question reasonably often. So the answer is something like this doable in any other programming language? Of course it is. There's no, is it cheaper to do here? Yes, it is, in a foreign environment. And this is where it gets to the second part, and that is we would have had lots of difficulties, or probably not be able to create this environment were it not for an existing Smalltalk system that allowed us to actually go and exercise these ideas. And this is even there, it was a reasonably long journey. It's now more than a decade that we started on this, and maybe even more, because it's based on some prior projects that were all done in a Smalltalk environment. And again, it is because of that environment that we were able to put together a new way of thinking. But now that we know what that new way is this implementable in another language? Sure it is. So at the end, like there are inspectors in the world. There are quite a number of them. And interestingly enough, they all show you this, right? All inspectors in the world, it shows you variables and values. It's not difficult to present, other. So for example, here's this is a table. It's not like it's difficult. So, but it does require one to think completely differently. And when we started, by the way, talking about UX design, we started from asking, what do developers do, right? And then, so today, for example, one of the questions I'm fond of asking is whether, where do people read code? So developers spend most of the time reading code, but it's interesting how basically they never have conversations about how they read code, not about the code they read, but about how they do the reading. So if you start looking at that, then we said, well, what can we do about this? And if you look at where does the reading happen? Where do developers read code? They read it in an editor, right? I'll say it again, editor, right? We used to have a very large problem typing things in. This was a really, really essential problem. But at the end, that's just half of the problem. So probably software is pretty much the only place where we are reading in an editor. For all other activities where some sort of digestion of data is involved, we are using other mediums that are not necessarily the editors. And that's basically where we started. So this is why the experience here is, it doesn't start from an editor, because the editor is the thing you should end up in, not the thing where you start from. It's a simple thing, but it has quite some implications. So coming back to your question, can this be implemented in another language? Yes. The difficulty is not the implementation. The difficulty is changing that perspective and making something that is implicit explicit. And that's the hardest thing.
Very interesting. So do you have something else in mind to like continue here, or if you want, I
just
can like
go
ahead
ahead
and
ask
questions.
Yeah, that's exactly.
Okay,
just
cool.
Go ahead, ask questions.
So since I like explored some of the language and some of the tools, even though I'm not proficient in them, obviously. The first question that came to my mind is how I really want to use this for my day-to-day life. But the things that I make are for people who would use them in their web browser or maybe in a mobile app. And so how can I use it for that? Like one example that I remember is that I think you showed some kind of analysis tool for a React TypeScript code base.
Yeah.
So maybe you can
yeah,
show
actually,
us that.
I kind of predicted that you will ask that, so I have the demo ready here.
Cool.
So the question is, this one goes into the area as to what exactly is Glamorous Toolkit for? Or when should you use it? Because like it looks like entertaining, but like, is this something practical? Can I extract something out of it? So here's what the way we look at it is, we are first and foremost solving the reading problem. So that this time the developers spend reading is actually the most manual possible way in which people can extract information out of systems. That's what reading is. So, and we're spending the largest chunk of our budget doing that. This is the single largest expense there is. Nobody talks about how this money is being spent. And that sounds amazing to me. So if people are looking for improving productivity, then that's one good place to focus on, because it's very likely that you can get low-hanging fruits very, very quickly. So one area, and there are a couple of areas that we have identified as, let's say, application areas for Glamorous Toolkit. Like replacing, muscle memory that's a hard thing. There are interesting editing options in Glamorous Toolkit. In fact, and one of the things that people maybe not know is that Glamorous Toolkit already is a language workbench. It can host other languages. In fact, it was made to host other languages. So one of the first application areas for Glamorous Toolkit is to build system-specific development environments. Now,
may I ask, what do you mean by hosting other languages?
So let's see. I'll go here. If I look here, this is a JavaScript parser, and if I look at how if I look at this implementation, it looks like it's like a normal Pharo class. But when I look inside, this is a parser definition. This is another language. This is not Pharo. And yet I can go in there and I can evaluate things. So I can say, okay, like this is name, let's find something which I know, or which is more interesting. Okay, let's say, for example, an if statement. I love if statements. So, okay, so this is the definition, right? And I can see, okay, this is an expression over here, which could be either an assignment or something else. And here I have, so this is a parser definition, right? But at the same time, I can take this one, and this is an if statement now, right? And I can say, okay, get a simulator on this if statement. So now if I do if x equals 42, then you say, well, return true. Right, and then here at the bottom, you see how this parser matched or didn't match, right? And you can see which of the parser worked and which one it didn't
This
work.
is just crazy.
So the second language that we are hosting in Glamorous Toolkit is the language with which we define the support for the other languages, of course. So, right, so because this is that language, and now here you're seeing it parsing JavaScript. But then in the same way, we can start to go and approach all sorts of other languages as well, and then provide editing, analysis, and yeah, if we connect also to a runtime, then all of a sudden, boom, you have a solution like that as well there. So this is one. That's what I'm saying is that this support already exists. It's built in. So event like right now there is no, if you want to go and develop or JavaScript, there is no out-of-the-box solution that would support it. But what we already have is the support for the analysis part. So what do I mean by the analysis part? Let's say that you have a system here, right? And this is, I'm just navigating. I just took Zooniverse. This is a React Native mobile application, and just something that I found. And so if you go here, right, I'm navigating now through my file system. This is something that what you would normally do. You will go to your, maybe your file finder, or maybe you'll go to your command line, and you would do things there. But then if I go and find an actual JavaScript file, right, I could, I can either look at it like this, or I can say, well, what if I want to do something with it? Let's say if I want to create a lint rule for it, right? How do you build a lint rule? Not how do you deploy a lint rule, but how do you build it? Because you would need an environment for that, right? And most people would just open some text editor that is just completely dead, and then you would go in there, right? But you'd have no mental model of, okay, what is the data structure that I'm actually going against? How would this look like? But then what I already showed you that I have a JavaScript parser. So if I open here an object playground, I have here a file reference pointing to this specific JavaScript file. And if I say, well, I just want to parse the contents of that file. And if I do this, what do I get? Well, I get an abstract syntax tree over here. Right, I can see it there, 1, 2, 3. The first one is an import token. Notice how if I click on things, it gets highlighted there, right? Or the other way around. If I click here on things, I get to see it in the abstract syntax tree. So now if you're gonna write your lint rule, you don't have to imagine anything. It's just a data structure. It's a tree. You're gonna write a query against the tree. So all that thing that about the people are saying, oh, creating static analysis tools, that's expensive. Normal developers will never do that. Of course, it's expensive if you don't make it apparent. But if I was going to say, here's a tree structure, go navigate it and find some pattern in there, is that going to be hard? People are doing this all the time, right? That's not hard at all. And if you make it apparent, then they will start writing it. Now, what happens once you have that? Well, once you have that, you can transform it into a fitness function. You can put it into constraint. You will put it into your continuous integration. And all of a sudden, your continuous integration will not be checking these generic rules about that, some God decided that this is how code should be, but it will be something that's specific to your system. And then this one then will lead to, by the way, architecture, the value of architecture doesn't come from what is common between systems. It comes from what is specific in your system. So if you're going to download a rule from the web and you're going to use it and I'm going to use it, then by definition, that rule must capture what's common between us, which also means that by definition, that rule will not capture what is valuable. It will capture, low-hanging fruits, but not valuable things. And when you care about things, then you're going to stop and you're going to encode the value in the assertion. And so that's just a very concrete direct application. Does that make sense?
Could you repeat, you encode the value in the assertion. Could you?
Have you ever downloaded a unit test from the web, from some others, somewhere, and applied a unit test to your system?
Almost, yeah, never. Never,
No,
yeah.
right? What do you do?
Which is
Well, you go
crazy,
to,
but you should.
no, you shouldn't. How could you? Because the
Ah,
value of the unit test, the value of the unit test is in the assertion that you're writing. And the assertion will capture value, which means that at the
ah,
moment when the test fails, you stop because you know that it captured value. And at the same time, you don't stop when you have 1,000 warnings or 10,000 warnings because you have no clue whether there's value there or not. Something failed, but that's easy to fail,
ah.
right? It's somebody else's problem. And that's the difference, right? That's the reason why people stop when the tests are green, or red, but they don't stop when the warnings, the lint warnings appear. Because the lint warnings were downloaded from the web and they are just generic, which means that they cannot capture what is specific. For example, if I'm going to take a lint rule and I'm just going to apply it on React, will it capture anything meaningful at the React level? No. It's just going to be just something. Who cares, right? And it's not relevant. And so let's go here back. And this, by the way, the same principle you can apply to any other data that you might have. So for example, here this is a JSON. And let's say that I'm interested to find out all the dependencies that start with React. It's a reasonable thing to ask, right? So what would one do? Well, maybe we could go and find something React, right? And see how many of those we find, right? But that's kind of like, you'll also find this one over here, which is in the dev dependencies. It's not quite the same. But on the other hand, this is a JSON. So this is not a text file. It's not just arbitrary text. It's a very, very structured text. So why don't I take advantage of that? So if I parse it, I could go and write a program over here, or in this case, it's already being made. So if I click on that button, I'm parsing it, and I get the result back. So what do I have here? Well, I have my dependencies there over here, right? And this is in this case, is a dictionary. So for a map in Java would be. And so here, if I say now, I want to find all the keys that begin with React. So what do I get now? Right? If I execute that, well, I get my 23 of those. That's it. And this was, right? It's straightforward. It's right there. Now notice how I switched between types of problems. And I never left my environment. Because, by the way, the I in IDE stands for integrated, which means that every time you leave, the I has failed. So,
Yeah.
and that's our guiding principle. Like, how do I ever need to leave when I want to reason about anything about my system? And our goal is to not have to leave. And so, of course, now for that, we build a language. But as I said, let's take a step further. So here, I just said, oh, here's a file, I want to see a tree. But let's say if I have, React components, they form a graph, right? I can embed components into other components, I can compose them out of, and they form a graph. And it's not uncommon for that graph to, to end up with cycles in the graph, only to find the cycles at runtime, right? So so at the end, right? And you'll say, well, okay, let's go and find those cycles. But then it turns out that this is not a trivial problem to have. It also turns out we just played with a mobile application recently, and not this one, but another one, and we got into the cyclic dependency problems within the first 2 weeks. Well, the whole thing lasted for 2 weeks, but we got into it, very, very quickly. And we said, well, surely there must be easy tools that will allow us to reason about that. And didn't seem to exist. It's like it's only the most popular framework, UI framework right now. So, well, it's a little strange that there is no such tool. So then, of course, what do we do in that situation? Well, in moldable development, if you follow this, then the idea is if your brain is not at ease with what you're seeing, you're likely missing a tool. I should only be reasoning about problems that I can nicely form it in my brain. Problem with my the challenge there is that I have limited piece of information I can put in my brain at the same time to reason about at one given time, right? But I have, you know, a gazillion of them in the system. So somebody has to do the filtering. And when people are doing reading, or you employing reading as a means to do that, what they're doing is, in fact, they're searching or visualizing rather than actually making decisions, which is what the goal of the exercise is. So in that situation, we stopped. When we got the first cycle, we stopped. We maybe tried to look at it and say, oh, no, this is too complicated. I don't know what's going on here. So we stopped and we built a little tool. And so that tool over here says, well, I want to transform the trees, so the abstract syntax tree now of my JavaScript, well, in this case, we use JSX. We want to transform the abstract syntax tree into a graph, which is exactly what people are doing whenever you get a JSON, right? And you're going to resolve your IDs, and then you'll build a connected model in memory, right? There's nothing complicated there. It's really the same. It's just made to appear, for whatever reason, to appear complicated. So here, what I have is a model that represents, like, is on top of the abstract syntax tree, and now it built a graph. So at that level, for example, we can talk about functions. And these would be JavaScript functions. But we could also, let's find something here. So this is a function, right? I can see this is a function object over there. And if I look at the source code, I don't know, it's a little bit slow. Yeah, okay. And I can see, okay, this is a function over here. But again, as I said, for this one doesn't give me React level component. So here I can also see on top of the JavaScript, then there is another thing that goes and really specifically only takes and looks at the React specific patterns and then extracts components and references. What does it mean? Well, here I have, as you saw here, I have 700 functions, but I only have 53 components. So given that this is a group, I can also see, well, I want to see how they're connected. And now I'm applying that pattern over there. And you know, again, the interesting thing here is that once you have this, right, then I can, this is not a dead picture. It's just something I can go and manipulate. This is the actual object behind. This is the actual component. So when I clicked on it, I actually get to a component which knows how to present itself. And so now I have a browser. But where am I? What's the name of this tool? So again, the only thing we've done was to decompose this whole space in little tiny operators that can be combined in many, many different ways. And through that, we can accommodate use cases that appear to be radically different, right? So the way you build a parser, the way you're going to navigate through your file system, and the way you're going to parse or reason about the React components are perceived to be fundamentally different, but they are really not, because if they would be, then I would not be able to handle them in the same metaphor. Because I haven't introduced anything else, right? It's just very, very simple in the end, right? The things that you learn are simple, but there are many things you can do with them. So, and that the reason or the way we got to this place is because we're looking at the environment as a language, not as a set of features. So we're looking at all of this. So the fact that this is an inspector that has views, the fact that the inspector has views, that's an operator. The fact that I can show connected object, that's another operator. And in fact, the whole language here is There's very few operators. So the fact that if I'm executing code or I'm clicking on something, I get just another object that I can visualize. That's just another operator. So with 3 or 4 of these, you can start to accommodate a lot. And then, of course, there are many other parts. But so when you look at Glamorous Toolkit, you will say, wow, but this is like a, everything for everybody kind of thing. And in a way it is, but it's like if you enumerate the features, it's going to be a very long list. If you enumerate the operators, it's going to be something that is really, really interesting and manageable. So there are 2 ways to look at that. That's why we don't necessarily have cheat sheets, which is what you have and see for tools, because those cheat sheets assume a very shallow level of interactivity, right? But once the tool, when there's no boundary, that illusion doesn't, it's just that, it's an illusion. So you shouldn't, like, we don't favor it, right? So it's a different way of handling this. So
okay,
go ahead.
So I don't want to change the topic unless you're done with this topic.
Yeah. So again, like here is this is a use case where you're saying it's something that you can do right now. There's no solution right there, very easy, where you can easily go and adjust tools for the purpose of how do I reason about my own system. And we can do this with JavaScript, we can do it with Java, we can do it with C#, PHP, even Delphi, all sorts of those languages. And the whole stack of how do we reason about it is also accessible. So you can go and extend it and so on. So one particular use case is this idea of steering agile architecture, software assessment. And that's a practical problem that people can go and use Glamorous Toolkit for, that complements existing environments. You don't have to replace them.
I see.
Okay, so let's go for the other topic.
Okay, so since a few of my friends are here, hi Puria, Alireza, Jonathan, and they're all web developers, I would ask another question about from our perspective. So I understand that you can do program analysis, more than just analysis, obviously, by, for example, using the parser here. I'm sort of thinking, what is left to do to be made, like in this Glamorous Toolkit image, for it to be able to like interface with like actual runtimes, right? Because like I can totally imagine developing a native app or a hybrid app or something like that in this environment, always opening up inspectors, all that stuff. I can even imagine having like writing a projection from the Pharo language, because I saw that the DSL for the view was super simple. Like it was, I think it can like project one-to-one to, for example, Swift UI or React or things like that, So I can see this becoming like a development environment to be used for a mobile app, and I think like there are 2 ways that it can go. So maybe you can tell me if that's the case. One way for it to go, for us to be able to like develop mobile apps, would be to just do it in Glamorous Toolkit, like the whole thing, and just like ship the image. Tell me if that's feasible at some point in the future. If not, maybe interfacing with some sort of runtime with V8, for example, or something like that. Is that feasible? And if it is, like, how can we help? How can people who are interested in that help, basically?
It's a very cool question. So both are possible, and in fact, both are desirable. So let's take the first one. So the question is, can we take this one and then deploy it on the mobile application? Can we do it right now? Right now, no. Is this possible? Yes. In fact, the reason we have, or one of the reasons why we have, at the moment, the graphical stack is based on Skia. and both because it gave us enough freedom to build on top, and then we can see what we can do. Everything else, everything that is in the image doesn't depend on Skia to be there, but practically this is what gets rendered, which means that we can go and deploy wherever Skia is deployable eventually. So mobile applications are totally within the game. So from that perspective, yeah, that's definitely possible. The only thing that we still need to do is package a virtual machine so that it can also run on those. But now talking about the other part, so this would mean using Glamorous Toolkit as an application platform, basically, and then deploying a GT-based app somewhere, and that's possible. But where we started from is the use case of the developer. So there would be, how do we, for example, you can imagine building JavaScript application in JavaScript and using Glamorous Toolkit as a development environment. That is certainly possible, and it's certainly something that, yeah, this whole environment was made to support. Right. So I just showed you that we already have pieces in place. It's just they're not packaged at the present time, but the principle is still the same.
Definitely. Maybe we can dig in a little bit more. So first of all, do you think, like, performance-wise, I mean, I know this is like a new rendering stack, obviously, and it takes years to optimize rendering stacks. So definitely, this doesn't represent what the system could be, and this is already like fast enough to do development in it. But like, do you think like there's some sort of ceiling to the performance, which would somehow limit the use cases that we have? Like, for example, you could say if your application is like, I don't know, does real-time game engine style rendering, or just wants to have like this really snappy UI, maybe this is not the right environment for it. Or if it is, then again, how can we help take it there? You know, as contributors, basically. Like, yeah.
Yeah, this is very cool. So first is, yeah, we did implement a new graphical stack, and the whole idea of the graphical stack is this, right? Is that this has this property of basically one DOM, right? This is what we call one rendering tree. So what do we mean by that? Just maybe very briefly, it means that, for example, everything in this scene, everything that you see here, so this piece of text, this word over here, this button, this projection here, everything that you see in this window is done exactly in one single rendering tree that is traversable in the same abstraction. So as just compare that one, for example, with HTML and SVG. SVG comes with its own abstraction, completely different, that it's hard to combine with the HTML part of the tree. Also, maybe a text editor is maybe going to be is a black box from the perspective of the DOM, because you don't see it. So if you look here at the text editor, for example, right? If I have, this is a piece of text, and let's paint every word differently. Maybe let's resize them a bit and let's rotate. So this, right? This is still working. This is still, it's the same thing. Every word here is an element in the DOM. Okay. So
cool.
Right. So if I look here, for example, in this one, what I can do now is, let's say I put here cursor, maybe I select, and now I'm going to look at the DOM. Okay, so I'm looking at how this DOM is implemented. I can see, okay, here I have an editor, and I have here a segment and another segment. And what is interesting here is that even the cursor here is an element in there, and so is the red box. Right, the red box is just, it's just there. So which means that now that's the reason why we can start combining things with all sorts of we can create interfaces that are really a little bit maybe complicated. For example, the other thing that the other part of this one rendering tree problem is that usually graphs are handled separately. Like graph libraries are different than widget libraries, right? They're like two different worlds. But here I have a tree scene, right? Just a tree of things. And if I expand that one, what do I get? Well, I get an actual full widgets here, right? And then here inside this piece of text, there is a little button there. If I expand that one, I will see this button expanded. So again, like this kind of interfaces today, we don't know another infrastructure where you can implement that. So that, okay, now maybe just to show you this. So here's there's a nice demo that shows the full-blown capabilities of the rendering part. So here you're seeing, well, I have here something like, an example. Example are like tests that return objects, and let's not go there today. But here basically it says, well, this one is based on some other example. And if I click on this one, I'll get the example over here on the right, right? And I can see, okay, there's another dot over here, I can expand it there. So look what happens if I scroll here on the left.
This right? Was very cool.
So what does it mean? Here it means that this dot and the line and this pane and the words inside, they're all part of the same tree, because otherwise I can't do that effect. And this dot, in fact, is actually added by the syntax highlighting as I type. And of course, it sounds crazy, but if you have one rendering tree, this is actually cheap to do. It's not difficult. And so if I maybe expand that one and I look at things, then okay, here for example, I can see, okay, self element, are they the same? I don't know. Okay, yeah, they look the same. But what's interesting here is that because these are now examples, right, and they are full, again, like this is a full editor over here, and I'm in a graph scene and I still have full editors. So, which means now that I can, because this is an example that's executable, I can inspect the results. I can see how things are being combined.
Oh, wow.
And I can flip, back and forth between different views, and I can see how things are being combined. Okay, this interface here, if you need this interface, I don't believe today there is any other infrastructure that would host something like that, and definitely not with the cost that you could have implementing it here. Okay, now this being said, right, everything you see here is it's achievable to render it easily at 60 frames per second, because there's no real bottleneck on the implementation. In fact, I think we got it reasonably optimized, or we know how to optimize it even further. So anything that the underlying infrastructure allows us to do, it's doable here. The other thing to know is that we have implemented the render layers, so compositing, which means that we can delegate any part of the scene to GPU, CPU, somewhere else, even if today the virtual machine is single, so it only runs on one processor, but the rendering is not anymore limited to that. So that's basically where it is. But now still the logic of what's going on in the Faro world today, most of it is actually just running, or all of it is at the moment running in the same processor. It's definitely possible to externalize some of the computation to maybe other processes, kind of like async in Node.js would do, but yeah, we are achieving this one on a single processor, on the logical side, with all the parallelization that Skia would offer on the lower level side. So
interesting.
So yeah, I'm sure there's a lot to to go from here. we can go way further than where we are, but it's also useful to know what would you like to use this for. So if you think about Glamorous Toolkit, or using Glamorous Toolkit as a way to deploy application, the question is what kind of applications. And today, it's particularly exquisite, I guess, at building browsing applications or things that require languages, or things of that nature. Or dedicated development environments for specific systems. Because that's where the focus was. So if people want to go and build, libraries of tons of widgets, it would be really, really awesome on top of this, and then would be much, much readier for for targeting other kinds of applications.
Two things that came to mind. One of them was that as you showed me this page, just having these arrows from one line into an inspector. There is this whole project done for P5.js. It's like a creative coding kind of library / environment, where people make audio visual stuff. And it was like a whole big project to get a web page looking like this, what you showed going. So like having like visualizing different parts of each code. But so that was like a whole project. This one, the way it looks is that like this workbench, it just emerges out of some principles. So like you don't have to like build the whole thing. Maybe you add some like sprinkle some goodies on top, but the fact that you can do this is just an emergence property of the underlying language. So that is really cool. A second thing is that I think in line with what Ali Reza asked, could you show us like, I think you had told us that there are companies using Glamorous Toolkit, or I think you guys would be consulting them could you show us like one practical example of how this is actually being used by you guys or in the wild?
So one of the let's take it one step. So one area, we are a consulting company. The Glamorous Toolkit is at the moment free and open source. No, it is free and open source. But we do want to have an environment, like an ecosystem around it, which would also allow people to sustain the development costs. We are so far we have bootstrapped this whole development by being a consulting company, and we are working, or in all our projects, we're using this technology for delivering, solving the problems for our customers. And what kind of problems are those? They fall into two large categories. On the one hand, deal with large legacy systems that people don't know what to do with. And in that situation, we're going to find ourselves building tools specifically like these ones, like these. But then not only the tools, but also building, rules, guiding the architecture. So from here, creating these functions, constraints, deploying them into the continuous integration, and then coaching also. Because what's interesting is that we can get the costs of reasoning about the architecture to be much, much lower, maybe an order of magnitude lower than they are today. And not only for technical people, but even more interesting for the business people. So most of our projects are actually working towards the business, not so much also with the technologists, but a lot with the business, because there's this very large divide between what technologists, people talk like, and what business people talk like or think like. And if you go towards the business, almost everybody we meet is scared because they have to make decisions on a daily basis on huge black boxes that nobody understands. And it's really a scary place to be. In fact, it's so excruciating because they have two pains at the same time. On the one hand, they are scared to change the system because they don't know what's going to, what side effects are going to be. On the other hand, they are afraid that they cannot change the system because by not doing it, they are getting crushed on the competition, on the market. So it's a really, really terrible place to be in, but it can be addressed by making the system explainable. So this is one level, one type of problems that we deal with. So we go into a legacy system and we basically tool it up, and then we coach both the business and the technologies. How do you steer agile architecture? How do you expose technical decisions such that everybody can understand what's going on there? How do you guide a long migration? And then we are only doing this through these kinds of tools. This is one. The second one is we're actually working with startups to create new, to help them create new domains. So you can think of it like executable domain-driven design, where we build the just a second, where we build the environment through. So in this case, we build the environment not on the technical side of things, but for the domain. So what do I mean by that? I'll show a demo in a second. I'll reload the code a bit. Okay, almost there. Yes. So this is an example of such a domain. So here, again, it's just the same environment where we were before. So you can see here we were doing that. But now I loaded some code, and in this code, when I load it, my front page changed. So it offers me some new entry points. So this is actually now we're into a presentation. So okay, here basically this is a restaurant automation system, and so here I have a room and table 1, table 2, and a kitchen, and the restaurant over here. And in there, I have a waiter at table 1 and table 2, and I have a cook in the kitchen. And then one of the problems in restaurants is how these people communicate with one another. And there's a lot of bottlenecks that come from there. And so here, a different model would be to find a way that they can communicate in a way that they don't have to know about each other. So an algorithm would look kind of like this. Let's say that John Waiter goes to table 1, talks with somebody, the customer wants a steak, and then John Waiter orders a steak at table 1, and then like this message can propagate because table doesn't know what to do, the room doesn't know what to do with it, and the cozy corner says, "Oh, I know what to do with it," and says, "Well, somebody should go and produce it, right?" And then eventually it goes to the cook. Now the cook has to wait, and after a while it says, "Okay, somebody should come and deliver it," right? And then this message goes back to the waiter. So this is something that we drew on the whiteboard. This is your normal domain-driven design. Okay, this is hand-drawn before we have the system. Now, after you have the system, right, you should never draw anything on the whiteboard, because it's like as soon as a human deems a representation interesting enough, it's the responsibility of the system to carry that representation forward. That's the only humane way.
As soon as a human being takes a representation seriously enough, it is
deems a representation meaningful. Like so, like two humans, they draw on the whiteboard, right? And they use this representation is meaningful for the exchange between the two brains. One brain is good enough, but two is even better, because now all of a sudden it's a language. Once this representation is deemed or passes that test, then it's the responsibility of the system to carry the representation forward. So what do I mean by that? What do I mean by that? Well, here's we've implemented the model here. So now we are after that, right? So if you can go and squint at it, but basically you can see here, okay, this is a venue, an area, and a contributor over here, and I can see they are all connected. I can, if I read the code, I can kind of imagine it, but if I execute the code, I don't have to imagine it. Because it's kind of like this. Okay, I don't have the 3D here, but but you get the idea, right? And then of course, because here in the previous on the whiteboard, I got this red thing that was transformed into the blue thing, right? So this implies that there's some computation somewhere. So I have here cozy corner, table 1, table 2, waiter, cook, kitchen. And now if I add behavior to this, which is just a model, right? It's just a bunch of objects, nothing really complicated. And then this is, I get a venue object that knows more things now, and it knows how to display itself. And then we can look at it like that, and then I can say, okay, the waiter will go at table 1 and place a message, place an order. So what's going to happen here? And the waiter goes to table 1 into the room, and then it goes there. Right? So if you can do this, right, then the conversations with business are completely changed. The normal humans can relate to the inside of this conversation, and I'm just showing you arbitrary objects. But normal humans can relate to these arbitrary objects in the development environment. And you can have normal, humane conversations about the inside of your software system. This unlocks a whole lot of, of potential. So, so from that perspective, this implementation here is a specification. It doesn't have to be the system, but it still has a lot of value. Because if I can take these things and I can make them examples, and after I have them as examples, because I also have a live notebook technology here. It means that, like if I go here and I see this is the actual demo that I just gave you, right? But it's a live document. This is a real document, and it has just executed live right now, right? And again, like notice how my environment now switched, and it kind of looks like a wiki. Right? But what are these? These are actually comments. This is a comment in this class. This document is just a comment. And then in this document, you notice how, because we have this super flexible, graphical stack, when the cursor goes here, the markup appears. When the cursor moves away, the markup disappears. So I don't have to have an edit and view mode, like this fancy thing that everybody says, oh, here's the edit mode, here's the view mode. So in the 21st century, we can think of it like this. And you get, again, this is actually a language, right? Which means that you can get completion here. So I can actually go and say, I get all the cozy corner examples, and then you get all the different kinds of, and it just happens live.
This is crazy.
Yeah, I know, but it's very cheap. So in fact, the implementation, the core of Glamorous Toolkit, combined with the core or with the part of Faro that we use, is about the same size as the distribution of Faro. And Faro is already a very condensed language and a very condensed environment. We can do much more within the same amount of effort or energy than people believe it's possible. So again, like here, we're using it for something we call executable specifications. And so one interesting scenario is actually we work with the startup, and then we produce an executable slide deck. So with the cost that other people create conference pages and documents and whatever, you can actually build something that is sound. This is how much the difference between, just looking at a text editor and reinventing the reading part is. Of course, now here you have the narrative part as well, which is another skill. Because you see, once you can start telling stories, all of a sudden that storytelling or the narrative skill is going to become important. So I believe that we will be having not just storytellers or UX designers on that level. We should have storytellers just pairing together with developers. In fact, that's how we're developing the whole Glamorous Toolkit. we are developing it by telling stories with one another or to one another through this. Every time our brain is not comfortable understanding something, there is some story that is missing, some narrative that is missing. So we just need to go and capture that one. So anyway, these are the two kinds of things that that we are doing in practice. These are real projects. Yeah, like if people want to work with us, would be, you know, like we are always happy to go and interact with people. But others can do exactly the same. It's just a matter of doing. But interestingly, both in the case of the legacy system and in this case, what we are building inside Glamorous Toolkit, it's complementary to what people perceive to be system development or, you know, software development. It's like here, for example, we are replacing the requirements document. But it also, like, you know, like if you go a step further and you say, okay, here I have, let's maybe maximize that. This is actually a UML diagram of the model. Because if you're gonna implement this one in another language, maybe JavaScript, maybe Java or something, Swift, this is the specification. And you can go here and see. And what's interesting is that once we take this and we combine it with the static analysis abilities that we have, we can actually trace the difference between you know, what business understands as specifications and the actual implementation. You can actually do a diff. So anyway.
Interesting. Aaron asked the question. If it's okay, I can take that one, even though I'm a complete noob.
Go ahead.
So I think, tell me if I'm right, the dollar sign and the curly braces, that is DSL, but what goes inside it is just pure small talk.
No. Okay, here is, this is a markup language. At the moment, it's a language.
So this is not small talk.
No, it's not small talk. That's another language, right? It's one of these other languages. So this is the third language actually that we're accommodating. It's kind of like a markdown language. But it's
I mean,
markdown
the markdown, yeah, but what goes inside the dollar sign and the curly braces? Like
this one is
when you write example colon.
Yeah, so this one here says, this one here is actually, okay, let's take the more interesting one. Let's take a look at this one. So here is this dollar example. You remember when I said that we have this thing which we call GD examples. This is like tests. The difference between an example and a test is that I have here a setup, right? I have an assertion, so that's like a test. All the way to here, it's a test. The difference is that in our case, the example returns an object. Let's just think of it. So it's crazy, but everybody's doing it in the same way. But just think of this. What is a test? A test is, I'm going to create this beautiful object. I'm going to ensure that it has a beautiful property that I care about. And then the best thing that I can possibly do with it is throw it away. Like, why throw it away? Why are we not returning it? Because in our environment, once I have an object, I can start having very interesting conversations with them. So after I'm finished with my normal example-driven development, I actually have the pieces that I need to build narratives. So this is what this thing here is. It simply says, oh, I want that example, and I just want to write a few pieces of text over here, and all of a sudden, I have a story that I can tell. And so they all tie together. So this markup over here is indeed linking to an example method defined in the image. Yes. So for example, here we can say, you know, maybe I don't want the code, and now all of a sudden the code disappears, and I just see the preview.
Okay, so this whole thing is a DSL, and then when you say UI price examples, does that mean that this object should be present in the image with that name? basically?
There is a method called so there is a class called uPriceExamples, and then there is a method called concrete price discounted, da, 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 da.
Uh-huh.
This method exists and it's in the image. So I can go and browse it. And if I browse it, it's going to be a method over here. It
Very
exists.
nice.
This is a method. It exists. And in fact, this comment here, this document is where? Well, let's look. It's in uPriceExamples. It's a comment in the class where I'm putting my tests. Again, like you take things that are, people think of them as being completely separate, but then they are not. Once you connect those, the composition becomes poof, it's right there. And it's it's straightforward. Well, it's not straightforward, but right. So this is what we are using Glamorous Toolkit for. So these are very, very concrete, real life situations that, and so for example, when it comes to the legacy system, it should not be reasonable for somebody from the outside to come in and start telling the team things that the team doesn't know. Let's say a team that works on the system for 10, 20 years. That should not be a reasonable thing. Yet we're doing this constantly. And it's not because we have, like we have, our brain is different. It's not. It's just because the idea of moldable development actually works. And that's what also a thing to consider about Glamorous Toolkit is that it was not created in a lab. These ideas have been validated for more than a decade in very, very concrete industrial projects.
Very nice. Okay, I have one last question. It might be an annoying question. You remember when Steve Jobs got a demo of some of the Smalltalk stuff, and then he was like, "Oh, the scrolling could be continuous." So I want to ask like one of those annoying questions, even though I'm no Steve Jobs. You see the box on the bottom left side that has a gray title bar. Can you like turn? Yeah. How hard is it to turn this color into like, let's say green, for example?
It's not hard. But we would have to. We can leave it for another time. But it isn't hard. So the question is how much more interesting is how do you go about learning this? Because we know that story with Steve Jobs. He asked this one then, but there were two things there that happened. First is that there was a break in between the question and the answer that people don't talk about. The second thing is nobody talks about how they found the place. Right, so it's the process, but that the second one is the most exciting thing. The process of how do you go and investigate how something appears. Where is, because basically you have like a, whatever system it is, there's no system that cannot look like there's this idea that, some systems are big balls of mud and some are really beautiful. There's no such thing. They're all big balls of mud. The only difference is what are you looking at? There's always going to be a perspective from which whatever you're looking at is going to look like a big mesh, big messy thing. So the question here is how do you find a thread that you're going to start pulling to figure things out, and what is the process that goes there, right? So and then this always relates to something you know, or if you don't know, how do you go and start to find the first thing you're going to know? So for example here, right, maybe we're going to go and look at we're going to say, well, I want this I want to have these halos over here, or to go and learn about the inside of that object. And this is an idea that came from, for example, from Squeak, the precursor or the Smalltalk system from which Faro got forked and on top of which Glamorous Toolkit is built. And then out of this, then we would get a new window, but now you don't see the window because I'm sharing only one of them. And that's going to be an inspector now where I will get to see the inside of that I'll get to see the inside of that one. But equally well, we could, once I know, let's say that this is actually a Glamorous Toolkit inspector, let's suppose that I know that, then I can say, okay, maybe I'm going to open one of those. So now what I'm having here is, this is now, I'm looking at the element holding the inspector object that I'm looking at. Like this, I just opened Glamorous Toolkit Inspector, but now I'm looking at the element that holds that one. So now one problem that you're having every time you're looking at anything like that is you're gonna want to know what's my DOM, right? So that's surprisingly difficult to learn about that one. But anyway, so in other graphical things. So now here is, okay, so I have my DOM, but which one is it, right? So if I now click on this button, I can start to see which ones are the ones that I'm interested in. Or maybe I'm not going to click on that. I'm going to open this and I'm going to see here a preview. And now I'm going to go and navigate to find the actual place that I'm actually care about,
Oh,
right?
God.
Again, like notice how
This is such an inception thing, you know?
It is an inception thing. It is inception, but it's one that you actually want, right? Because I'm using exactly the same mechanism that I was using to reason about anything else. And I'm reasoning about this problem that they just appeared. Right. So it will go like that.
Yes, wow. Maybe you can leave that as an exercise for the reader.
Yeah,
like I want
exactly.
to I want to try that myself now.
Yes.
How did you make the little circles, colorful circles appear?
It's Alt Shift click.
Alt Shift click.
Yeah,
okay.
Those will be the hellos, and then you click on the blue button. So this is not the most developed widget. In fact, that's the oldest. That's the oldest thing we have in the graphical stack, and we didn't get to optimize it after we implemented widgets.
I see. Well, I don't have any more questions. I'm just excited to go try this myself.
Excellent. Well, thank you very much for the patience and for the interest. And
thank you for.
Let's keep the conversation going.
Definitely.
Great.
Thank you, Tudor. Thank you so much. This was a lot of fun and just learned a lot.
Thank you. See you.